Wow, I wasn't expecting quite so many people to not only be interested in listening to talk about databases, but a very specific kind of bit of talking about databases, which is table partitioning. Just out of interest, before I start, how many of you here are using Postgres at the moment? Oh, good, I like that. And how many of you already have partition tables? Okay, so you people can keep me in check and see if I say anything that you don't think is right. So I'm Karen Jex. I'm a Senior Solutions Architect at Crunchy Data, and I am very, very fortunate. This is my third time speaking at a PyCon Italia, and I am so, so happy that you've invited me back to speak to you, so thank you. Okay, let's get started. So I always feel the need to get my confession out of the way before I get too far into a talk at a developer conference. I'm not a developer, I'm sorry. But as you can see from the illustration of my career so far, I do at least know about databases. So I was a database administrator for about 20 years, then I became a database consultant, and now I'm a senior solutions architect. So I don't have database in the job title anymore, but I do only work with database environments, and in particular Postgres. I've worked with a lot of developers in that time. And I've learned a lot from the developers that I've worked with, and I try really hard to kind of give back and help to share what I know about databases. The photo is me in my happy place on one of my local bike trails, so splattered in mud and in the sunshine there. I'm also on the PostgreSQL Europe Board of Directors, and I'm leading the PostgreSQL Europe Diversity Task Force, so feel free to come and find me if you want to talk about either of those things. And I give talks at Postgres conferences and at developer conferences like this one so that I can share database knowledge and spread the love for Postgres. So if you've got huge database tables, or if you expect that you're going to have huge database tables in the future, then you're probably going to start to think about partitioning to make them easier to manage. And you've probably got lots of questions about how to go about doing that and what the best practices are. So I work with lots of customers who've already gone through that thought process, and this presentation is based on the questions that they asked along the way and the things that they learned. And in fact, it was one of my customers that first suggested that I put this talk together, and I said, oh, it's going to be a bit dry just talking about partitions. I'm not sure if anyone's actually interested in that. But I gave a first version of it to a group of developers who seemed to enjoy it. So here we go. So we'll do an introduction, talk about what is table partitioning and how does it work, look at some of the advantages of table partitioning, how you go about choosing a partition key, how you decide which types of partitioning you need, and any other things that you need to think about. Think about whether native Postgres partitioning is enough for what you need to do, or whether you need to use other tools such as pgpartman to help you manage your tables. Look at how you would need to design your application with partitioning in mind, and what kind of applications you would need to change if you're partitioning in an existing application database. And if that's the case, how can you partition existing tables with minimum downtime? And finally, are there any potential pitfalls and things that you need to avoid? And if so, how can you avoid those? So first of all, introduction to table partitioning. What is table partitioning? How does it work? And what are the different types of partitioning? So partitioning is basically taking your huge table or tables and splitting it into smaller pieces that are easier to manage. So you take what's logically one large table and you separate it out into smaller physical pieces, i.e. multiple smaller tables. So each partition is a mini table. So let's look at an example. Imagine that you've got a huge orders table that contains orders for different stores. You could partition that by store ID with one partition for each store. So each partition will just contain the rows for a given store ID. So in this case, store ID is known as the partition key. So when we talk about partition key, it's the column or columns that we're splitting our data on. If you select from your main table, orders, you'll still see all of the rows, but it doesn't actually physically contain any data. All of the data is physically stored at the partition level. So we can see now we've created ourselves one partition per store. We've got the orders Bologna partition that contains just the rows with the store ID BOL, etc. The customer ID and the order date columns and the data are still there. I've just removed them to make it easier to see on the screen. So you've got different types of partitioning based on how you want to separate out your data. List partitioning, where each partition contains one or more distinct values of the partition key. So that's what we just saw with our orders table separated by store ID. Range partitioning, where each partition contains a range of values of the partition key between X and Y. Hash partitioning, where each partition's a bucket of values of the partition key. And then we also have what we call composite partitioning, which isn't actually a partitioning type, but it's just where you use a combination of one or more of those types of partitioning in the same table. So let's look at each of those in a bit more detail. List partitioning, so that's what we already saw briefly. Each partition contains rows with one or more specific values of the partition key. It's good if you've got a database that's easily separated by a common field across your entire data set. So that previous example where we partitioned by store ID was an example of list partitioning with one list per partition. Alternatively, if your orders table contains a region column, for example, you could partition by region with one or more regions per cluster. And this is a two-step process, creating a partition table. So first, you create the main table and you state what type of partitioning you want and which column or columns you're using as the partition key. And then you create the individual partitions. So for each individual partition, you say which values of the partition key, i.e. which regions in this example are going to go into that partition, and which table it's a partition of. So note, the partitions are child tables of your main partitioned table. Range partitioning is probably the most common type of partitioning. It's often used where you've got time or integer series data. So the table's partitioned into ranges of values of the partition key. So here, for example, I've created partitions for years 2024 and 2025. Note that the range boundaries are inclusive at the lower end and exclusive at the upper end. So the 2025 partition includes the values for the 1st of January 2025, but not for the 1st of January 2026. Also important to note, the ranges of values that you assign to the partitions mustn't overlap, because otherwise Postgres won't know which partition a row should go into. Hash partitioning is useful if you need to partition a huge table, but your data doesn't have a clearly defined pattern to it. So the partitions are effectively buckets of values. To create your hash partitions, you decide how many partitions you want, so that's your modulus, and then each partition will contain the rows where the hash of the partition key divided by the modulus produces the specified remainder. You can actually get complicated and have different modulus within your same table if you want different sized partitions, but that's starting to get into the realms of more complicated. Okay, so what are the advantages of partitioning? Partition tables can make it much easier to manage your data lifecycle. Maintenance tasks, such as vacuum, analyze, index rebuilds, etc., can be faster and easier. You can use partitions to separate out data if you've got a multi-tenant environment. And although query performance is often what comes to mind first for most people when they think about partitioning huge tables, it's not actually the main reason for using partition tables, so I've put it at the end of the list. In terms of data lifecycle, partitioning can make it easy to store just the data you need, which can help you with cost reduction. This is an image from a Crunchy Data blog post. There are quite a few on the subject of partitioning, and I've given a list of those later on in the talk. So to go back to our earlier example where we've got that one big orders table, if you wanted to archive or purge all of the 2023 data, you'd need to do a delete. And that could be time consuming, it would generate wall, it would leave bloat, and you'd then have to vacuum your table. If, on the other hand, you've partitioned your table by range, so on the order date column, and here I've done one partition per year, you could just drop the orders 2023 partition, which is a much, much faster and cleaner operation. Alternatively, if you don't want to get rid of that data just yet, but you don't want it to be a part of the main table anymore, you can use the detach partition command, so it now becomes a separate table in its own right. Similarly, instead of doing a bulk insert into a table, say you needed to get all of the 2022 orders into the table, you can create a new table, orders 2022, and I've used the syntax here like orders so that I don't have to type out the list of columns and make sure I've got the definition exactly the same. You load the data into that new table. You can perform any checks that you need to do, data validation, etc., in that new table. And then you just attach it as a partition of your orders table, so it's now part of your main table. You can also specify different table spaces for each of your different partitions. So you could send infrequently accessed data off to cheaper and slower storage media. Note, I'm not actually condoning the use of floppy disks for storing your database. Operations such as vacuum, analyze, and index rebuilds won't necessarily take less time overall, but you can do one partition at a time. You don't have to wait for the operation to complete over your entire table or your entire index, so you can schedule that into smaller maintenance windows. Multi-tenancy, so if you've got a multi-tenant environment where your database hosts multiple customers or applications, partitioning is one of the really useful techniques that you can use to help manage that. So each tenant, for example, I'm imagining here that the stores in my example database are separate tenants. They might be independent franchises or that kind of thing. So each tenant will access just its own data, which will be in a separate partition. Some of the tables might contain shared reference or management data, so things like the list of stores and products here I've shown as non-partitioned. So query performance, as I mentioned, people tend to assume that they'll automatically get better query performance from a partition table. And it is true that in a lot of cases, partitioning can lead to better query performance, but it's typically not the main reason to implement partitioning, and there are often other things that you can look at first if you want to increase query performance. This is another example from one of the blog posts, just showing a table that's partitioned by range on a date field. If your query or most of your queries are only looking at, say, a couple of week time period, then if it's partitioned, Postgres could scan just the partitions it needs rather than having to look through the entire data set. So it does this using a technique called partition pruning. If your query filters on your partition key, Postgres can use the partition constraint, so the constraint that says which rows are in each partition, to decide which partitions couldn't possibly contain the data that you're looking for. So it can just ignore those ones and only include the partitions that might contain the data you need. That partition pruning can happen not just during the planning phase, but it can also happen during execution of the query. So if values get evaluated during execution and it realizes it can prune more partitions, it will get rid of them during execution as well. This is something that can be really, really useful if most of your heavily accessed data is found just in a very small number of partitions, because then Postgres can ignore most of the partitions most of the time.
Okay, when and why would you partition your tables? Referring back to the image from the first slide, most of the benefits of partitioning come once you have very large tables. And of course, what constitutes a very large table is hugely subjective, and it will very much be application dependent. But as a rule of thumb, if your maintenance tasks, such as vacuum and analyze, are taking too long, they don't fit into your maintenance window, for example, if your indexes take too long to rebuild, if you need to be able to purge large quantities of data, if your application is always filtering on the same certain value, and if you have tables that don't fit into memory, you might want to start looking at partitioning. How do you choose your partition key? How do you decide which type of partitions you need? Which tables should be partitioned? And what else do you need to think about? So we've looked briefly at some of these things already. I'll just try and bring some of that information together. So you need to think about how your data is accessed. Is there just a small subset of active data? Do most of your queries filter on the same value? Does data get accessed by geographical region? Is the data accessed by date? Is it just the more recent dates that are frequently accessed? And how's the data managed? Do you need to be able to bulk load and or bulk delete data? Do you need to keep a rolling number of months or years in your data set? Do you need to separate data for different tenants? If your data is most often accessed by store ID and the data is managed per store, as in our multi-tenant example, you'll probably implement list partitioning with store ID as your partition key. If the data is most often accessed by and managed by date, then you'll probably put range partitioning in place with order date as the partition key. And in this case, I've used one partition per year. If you've got a combination, I'm not expecting people to see the detail of this. For example, if you're generally accessing the data per store, but you need to be able to manage your data also by year, then you might choose to partition on store and sub-partition on date. So notice we're combining list and range partitioning within the same table here. And as mentioned earlier, you don't necessarily want to partition all of the tables. Some tables are too small to be worth partitioning. Some tables are shared reference tables and don't naturally have a way to split them into partitions. And the million-dollar question, do you or don't you create a default partition? It's kind of the junk drawer of the partition world. So anything that doesn't neatly fit into one of the partitions you've defined will go into the default partition. Lots of customers ask me whether or not it's good practice to create a default partition. And as someone who does consultancy, I hate saying it depends. But, okay, on the positive side, if you've got a default partition, you won't get errors when you insert data that doesn't belong to an existing partition. You don't need to decide in advance what data you're going to have in your table and therefore which partitions you need. On the other hand, if there's no partition created for the data you're trying to insert, maybe it doesn't actually belong in the table at all. You'll probably end up having to do data validation and cleansing later instead. Also, if you've got a default partition and you add a new partition to your table later, Postgres has to check every single entry in that default partition to make sure it doesn't contain any rows that should actually be in that new partition that you're trying to create. If it finds any, that check will fail, and you'll have an exclusive lock on the entire partition table during that check. Is Postgres native partitioning enough to help you manage your partitions, or do you need to look at a tool for partition management, such as pgpartman? pgpartman is a Postgres extension for partition management. It helps you to do things like automating creation and deletion of your partitions based on retention periods. So to decide whether or not you need it, you need to think about what does or doesn't native Postgres partitioning do for you. So we've looked at a lot of things it already does, and I'll quickly cover some of the limitations in a minute. So what limitations does pgpartman make up for, and do you need those features and functionality that are only available in pgpartman? I'm going to gloss past that slide because I've just briefly mentioned that. I will share the slides afterwards for anything that I need to gloss over. And as promised, I'll share here the links to Crunchy Data blog posts about PG Partman. How do you need to design your application to make the best use of partitioning? What changes do you need to make to an existing application? Well, you'll probably need to implement schema changes. You'll often need to change the design of your queries, and you need to look at how you're going to do that partition management. In terms of schema changes, you need to have a partition key in all of your partition tables, or the tables that will be partitioned, including child tables where you wouldn't naturally include that column. If it's a multi-tenant environment and each partition's for a different customer or tenant, you'll probably want to think about row-level security to make sure each tenant only has access to their own rows. And partitioning generally works best if the application is designed from the ground up with partitioning in mind. So in particular, make sure that the queries actually filter on your partitioning key. Make sure you know in advance how you're going to manage the partitions. Will it be done via the application or via separate admin tasks? And will you use PG Partman for it? Briefly, how do you go about partitioning existing tables with minimum downtime? It's complicated. You can't convert a non-partition table to a partition table or vice versa. You need to create a new partition table and migrate the data into it. So it's not just complicated, but it's also time-consuming, and it generally requires downtime, which is another reason to consider partitioning right at the beginning of the development of a new application. So PG Partman does have some features that can help you do this. It's got an offline method and an online method, but each of them includes multiple steps and still requires some downtime. So I've included diagrams just to show how that's done, but it's just to give you an idea of the fact that this is not a simple one-step process. So this is the diagram of how to perform an offline partitioning. And then the online method, which is more complicated, but does let you do it with minimal downtime, takes 2 slides to illustrate because there are so many steps involved. I have included a link to the documentation that gives you the full instructions if you decide that you want or need to do that. Okay, so finally, are there potential pitfalls? And if so, how can they be avoided? There are some limitations that apply to partition tables. I've already mentioned some of them, and some things that you need to be aware of. To create a unique or primary key constraint on a partition table, you have to have all of your partition key columns in the primary key constraint. And the partition keys can't include any expressions or function calls. This is because we don't yet have global indexes on partition table. An index on a partition table is actually a set of small indexes, each on the individual partitions. And then a few more limitations here, such as you can't have any other parents than the partition table it's a partition of. You have to have the same columns in the parent and the child. And then certain constraints are inherited by all of the partitions. They can't be just on individual partitions. The more partition tables you've got, the more objects you have in your database to look after, so you need to take care of managing those. And performance, it's not always just a performance improvement. You need to make sure you're actually making things better, so your application needs to be aware of the partitions, queries need to filter on the partition key, and you need to test, and you might need to rewrite queries to make sure that there are no regressions. So partitioning can be a really, really useful tool to make huge tables easier to manage. PG Partman can help if you need features that don't yet exist in native Postgres partitioning. Choose the partition keys and the type of partitioning based on the way your data is accessed, the way your data has to be retained, and the maintenance of your data. And partitioning existing tables will require complex maintenance and potentially downtime, so partition early if you know you're going to need it. And they're just the links, and thank you very much.
Thank you so much, Karen. And thank you for being here. So now we're going to pass on to Q&A. And okay, so
Can you just choose the easy ones, please?
I will try my best. Okay, so one of the first questions is, when is a good time for partitioning table size rows? But as you have said, well, you go.
Yeah, it is very much an it depends kind of thing. I mean, often you'll want your active data set, if you can, to fit in memory. So that means like if you can have partitions that fit in memory, that's great. So if your full database is much, full tables bigger than that, that can be a good time. But yeah, basically, if things are taking too long and if it's too difficult to manage.
Okay, thank you. So the next question would be how to configure Django, ORM, or other frameworks to use this feature?
Oh, ouch. So I finally learnt to use Django at the beginning of this year. My Django foo is not quite good enough to answer that question yet, but I will take a note of that and I will find the answer and add it into the slides.
Super. Thanks. So next, what happens on the 1st of January if you forgot to create a partition for the new year?
So if you've got the default partition, it will go into the default partition. If not, it will fail. Your insert will fail. Or if you're using PG Partman, you can have that set up to automatically create the partitions that you need for you.
Thanks. Up to the next one. If you partition by range and you attempt to insert a row with a partition key value outside of the partition ranges, what happens to that row, e.g. after a partition is detached? Should I read it?
Okay, so that's kind of similar to the previous question, I think. So basically that row, unless you have a default partition, it wouldn't even exist in your database because it would in your table because it wouldn't get there. So yeah.
Okay, so are the indexes global and include all partitions or local for each partition?
So I got to that right at the very end. They are local. There is a lot of talk amongst Postgres developers about implementing global indexes on partition tables, and I very, very much hope that that gets implemented soon. But at the moment, they're all local indexes, one small index per partition.
Thank you. And how to handle a query to return data from multiple partitions?
You don't need to do anything. If you query the parent table, so just query the table as if it wasn't partitioned, it will return the data from whichever partitions the data's in.
And then what is the overhead of using partitioning?
So the overhead is really that maintenance overhead. It's the fact that you've got all of these objects, you've got many more objects, you've got to make sure that you've got the partitions defined for your data, for all the different data, the value of all the different values of your partition key. So yeah.
Okay. And how would you go to track performance of partitions? Are there specific tools you recommend?
To track performance, is that?
Yeah.
So I guess it kind of depends what you're thinking. If you're thinking about your query performance, then pgstat statements is a really simple thing that we often use, which is a Postgres extension that almost everybody installs and activates by default, which lets you see which statements have run in your database, how long they've run for, that kind of thing. So you'd get stats, so you can compare with and without partitioning, that kind of thing. Other things, it's going to be your standard test suite, really. So make sure that you're not introducing regressions into your loading, your purging of data, your queries, your inserts, etc.
And I think we have time for a last question. Are constraints enforced across table partitions? Are there performance pitfalls?
So constraints, you can have foreign key constraints between partition tables. That's absolutely fine. So that's enforced. Most of the constraints will be enforced per partition of your table, again, because of that local rather than global indexing. Performance pitfalls, it's mainly just making sure that you are getting benefits from partitioning. So making sure that you're actually using your partition key as a filter in your queries, even if it wouldn't naturally appear there. If you want to be able to do partition pruning, where you just look at certain partitions, make sure that you've actually included that in your queries.
Okay, thank you very much. That will be it for today.
Thank you.